As we turn our attention to functions, one of the major topics we talk about is domain and range. So our objective for this lesson is that we're going to be able to determine domain and range. We'll start with sets of numbers and then we'll take a look at some of the graphs as well. But first of all, just a reminder, a function is a relation. A relation is a set of ordered pairs where the domain values or the input values, the first values, are never repeated. So for every input, there's only one output for it. So as we look at that, the domain is the set of input values. Now we typically use x and y's for our functions. So if we are using x and y's, those are the x values. The first values, the ones that we put into the function. The range, on the other hand, is the set of second values or the output. So the set of output values are usually associated with the y values. If we use different variables, these would be different. But we also refer to the domain, the x values, oftentimes as the independent variable, and the y values as the dependent variable. Another term we sometimes will use is abscissa with the x and ordinate with the y. Now let's look at these examples here. To determine the domain and range, we just look at the x values for the domain. So I'll say for D, my domain is just this list of x values. So -8, -3, 0, 4, and 10. My range, on the other hand, is the set of second values or the output of this. And we get these second values and just list them in a set, -6, -1, 2, 6, and 12. Now, looking at the second one, this is in set notation, solution set, whereas this was a table or a chart. So on this one, the domain, we just look at each ordered pair and pick the first value. So my domain is 16, 21, and 50. Whereas my range are all the second values, 4, and then notice that we don't have to repeat the 4 because 4 is the only one that we have. So we'll just list it once, and that's my range. So looking at this last one, our domain is this is where we use these arrows. It just means that this number results in that number. So input and output. So the arrow direction makes a difference. So we start with the -1, so that's the first value. So -1 is an input, 0 and 3 are my inputs for my domain, and my range are just the two values of 100 and 200 for the range. When working with domain and range, we can also look at graphs. In this instance, we're given a rule for the function, and we're going to use the domain that's given to us to determine what the range is and also what the graph looks like. So if we look at this expression here, this equation, we could think of it as y equals x plus 1. That will help us understand how we're going to graph it using my x-axis and my y-axis. I'm going to set up a table here and put in some values. So if I want to put in some values, my domain, it says start at -5, and we're going to go all the way to 2 but not include 2. Now what I'm going to do is I'm going to actually find out what the value is for 2 when I get to my graph, but I'm going to put an open dot on it because it doesn't include that. But I'm going to have a closed dot on this one because it does include that value. So if I go with -5, maybe I'll put in -1, put in 0, and then 1. So just a few values. So -5, if I put it in here and add 1, I get -4. -1 plus 1 gives me 0. 0 plus 1 gives me 1, and 1 plus 1 gives me 2. Let's go ahead and plot those points. So at -5, I go down to -4 down here. -1, I'm going to go to 0. At 1, I'm going to go, at 0, I'm going to go up to 1. And then at 1, I'm going to go up to 2. And then if I were to put in 2, I get 2 plus 1 is 3. And so I'm going to put at 2 an open dot there because we can't forget all the fractions between 1 and 2. They're included in this domain, 1.5, 1.9, so we want to go all the way there. And what I'm going to do is I'm going to connect them because it's all these values going from the one to the other. So this is what it looks like. It doesn't have arrows on the end. Instead, it has a solid dot on this end and an open dot on that end because of what the domain tells me. So if you look at these values, my range, it's going to go from, notice that this value down here, it started at -4. So the first value is -4. Then my y values, the ranges are based on the y values. Y is going to go all the way up to, but not include. Now remember when we took 2 and added 1, we got up to 3. So they're going to be all the values just less than 3. So we can use this domain to come up with what our graph is, but this doesn't have arrows on it. It stops at those values, and then we can look to see what up and down range values, the y values, are covered by that graph as well. Now we're going to take the domain and range of functions and we're going to look at a graph that's already established and look at the graph to determine what the domain and range is. So first of all, we want to make sure we understand from the graph how to read it. Domain, since it's the x values, what we're looking for here is how far it goes side to side. So look for the side-to-side values, how far it goes. For the range, we look for how far up and down it goes. That's where the y's go. So look to the up and down direction. So x's are left to right, side to side, and the y's are up and down. So looking at this graph to state the domain and range, what you do is think about how far to the left I go over here. Now, if you kind of think of it in terms of how far over I've gone, notice I only go over to -2, and it's a closed dot, so I'm going to have -2 is less than or equal to my x, and then if I go over here, how far over I go is only over to the 1. So that's going to be less than or equal to 1 because it's also closed dot. Now, for my range, I look to see how far up and down I go. How far up I go is I go up to a 3. So the range is going to have the highest value of a 3. And then when I go down, notice that the lowest value it goes to is -1. So I have a -1, and this is going to be where my y's are restricted for it. So that gives me my left to right and my up and down for this graph. This one, I added a little bit of a change to it by putting an open dot there. So when I look to where I'm going from left to right, over to the left, I go all the way out to -3, but don't include it. So I'm going to have a -3 and with just a less than, because it doesn't include that, but it includes everything from -2 and between -2 and -3, like -2.2, -2.75, all those numbers. When I go over to the right, notice because of that arrow, it implies it just keeps going to the right. And so this arrow means that I'm only going to have x is greater than -3. So instead of writing it as a between, because we don't want to write it this way with infinity, so what we would just do is simplify this and write it as x is greater than -3. Now for the range, similarly, how far up it goes is the furthest up it goes is here to -1 on the axis, on the y-axis, but then it goes down from there and the arrow implies that it keeps going down. And so this, my y values are going to be at the highest point, just less than -1, and then just keep going less and less and less. So my range is all y values less than -1. So on this one, looks like an absolute value graph with a V. So my domain, I can determine it the same way. How far to the left do I go? Well, I stop at 0. How far to the right do I go? I stop at 5. The 0 is included, the 5 is not. And so I'm going to have my x's, they're going to be less than 5, but they're going to be greater than or equal to 0. Okay, so they go between 0 and 5. My range now, you have to think up and down. This dot doesn't come into play because it's neither the highest point or the lowest point. The highest point on this graph is a 5, that's the highest it goes, and the lowest is right here in the middle part of the graph, it goes to 2 here. So the y values go between 2 and 5, and both of them are solid dots, so I'm going to have my y values less than or equal to 5, and they're going to be greater than or equal to 2 for my range. So to do domain and range, you want to be thinking about domain as the input values or the x's, the range as the y values or the output of the function. And we can both look at the sets and how they're given in different notation, or at the graphs. If we're given a rule and the domain, find the range. Or if we're given the graph, determine from the graph what the domain and the range is of the function.